Hi, I'm Emily from emilylearning.com. So in this video, we'll be going through paper 1 of PRSS chemistry prelim paper. So let's get started. Question 1. So a mixture is separated using the apparatus shown. So what is the likely identity of this mixture? So if you take a look at this, we know that it is a filtration setup. And from here, we know that we are going to put the mixture through and the filtration will occur. So filtration separates a solid from a liquid. So in other words, the mixture that we are looking at is a solid and a liquid. In option A, we have aqueous copper 2 sulfate and aqueous sodium carbonate. Both are aqueous, so there will be no separation. B, you have aqueous copper 2 sulfate and calcium carbonate. So aqueous copper 2 sulfate is a liquid, right? It's a solution. Calcium carbonate, it will not dissolve in the water because it is insoluble, so it is a solid. So we have a liquid here, which is aqueous copper 2 sulfate, and a solid, which is calcium carbonate. So therefore, we'll be able to separate them. So the answer for 1 should be B. Before we go on, let's take a look at why B and C are wrong. Sorry, C and D are wrong. So copper and sulfur, they are all solid, so there will be no separation. All of them will remain as the residue on the filter paper. Ethanol and ethanoic acid both are liquid, so they will both pass through the filter paper and be found in the filtrate. There will be no separation. Moving on to question 2, the formula of zinc oxide can be investigated by using the fact that when zinc is heated, it reacts with oxygen to form zinc oxide. So we know that zinc reacts with oxygen to form zinc oxide. Okay, and we need heat. So which apparatus is used for this investigation? So we want to find what is the formula of zinc oxide, right? Is it ZnO, is it Zn2O, or so on? Okay, so what we would need is to basically know how much zinc we start off with. Okay, and then we could also find how much ZnO that we end off with. Okay. Okay, and to find the amount of oxygen or the mass of oxygen that has reacted, you simply take the mass of ZnO formed minus the mass of zinc. Because when you have a reaction, okay, what is used, okay, that there will always be mass balance. So what is here should be equals to what is here. What has reacted will be equals to what is formed. So for this type of reactions, right, this heating type of reactions, okay, we usually use a crucible and a mass balance. So the answer is 2 and 3, which is C. Okay, we seldom use the gas syringe. Of course, you can say that, oh, I can measure the volume of the gas, okay, that is being used. So I find out what is the initial volume of gas and what is the final volume. And from there, I will be able to determine the volume of oxygen that has reacted. And from there, I can find the mass and so on. Okay, there are some problems with this. Okay, so of course, we can keep. So the first problem is the volume of gas, the number of, so molar volume, the molar volume of gas is equals to 24 dm³ only at room temperature and pressure. If the temperature changes, this is not applicable, right? Okay, then it is usually also harder to measure the volume of gas compared to the mass. Okay, and finally, right, we want if you want to have excess oxygen, okay, so usually we want to have excess oxygen to make sure that all the zinc has reacted. So using this setup, it is you might not have excess oxygen. All right, so typically for heating experiments where we need to heat to decompose something or to react something with oxygen, we usually use the crucible and a balance. Okay, so what we'll do is you first start off by measuring the mass of zinc that you place in the crucible. Then you will start heating it. Alright, so you will keep heating. Okay, after heating for some time, you measure the mass. Okay, then you heat again. Okay, you only stop measuring the mass when the mass becomes stable. Okay, that means the mass, okay, so this is time, this is mass of substance plus crucible. Okay, the mass of the crucible should remain the same. So initially you start off with the mass of the zinc plus the crucible, then because it reacts with oxygen, okay, the mass should increase. So as you continue heating, right, the mass will increase until beyond a certain point, the mass just remains the same. When the mass remains the same, it tells you that the reaction has stopped, all the zinc has reacted with the oxygen. Okay, so you can actually stop the reaction already. So usually for this type of heating experiments, we use crucible and balance to investigate it. We seldom use this gas syringe. Okay, it is more tedious and it is usually less accurate, and it might not have excess oxygen. Using the crucible, you definitely have excess oxygen because oxygen or air is everywhere. All right. Now moving on to question 3, which statement about the states of matter is correct? So states of matter, we are looking at solid, liquid and gas. So we are looking also at the change in state. So for example, boiling, condensation, freezing and melting, as well as sublimation. So let's look at this. When a gas cools, the particle cannot vibrate about its fixed position. No, when a gas cools, okay, it becomes a liquid. Okay, for a liquid, the gas particles, they move about they move among themselves, right, within the volume of the liquid. Okay, when a liquid freezes, it becomes a solid and energy is released to the surrounding. Yes, this is true. So when a liquid freezes, it becomes solid, right, because liquid to solid, this process is called freezing. Okay, and when there's a freezing, this is an exothermic reaction, so energy is lost to the surrounding or released to the surrounding. So B is the answer. Next, when a solid is heated, the size of the particles increases. No, when a solid is heated, the volume of the solid increases because the particles are slightly further apart, but the size of the particles, like for example your carbon atoms, the size of them will not change. The size of the atoms, the size of the molecules do not change as long as it is the same type of molecule or atoms. Okay, when you heat something, it expands only because the particles are further apart, nothing to do with the size. So C is wrong. When a solid melts, the particles get further apart and have less energy. So when a solid melts, it becomes a liquid, right? So it is true the particles get further apart. Okay, and the particles can now move faster. Okay, and therefore they have more energy, not less energy. So therefore D is wrong, and the answer for 3 is B. Let's take a look at question 4. So in question 4, you are given the melting and boiling point of some gases in air. Okay, next you are asked, at which temperature will oxygen be the only liquid present? So in other words, at that temperature, only oxygen is a liquid, the rest are not liquid. So when we are given melting and boiling point, we know that the higher the temperature, it moves from solid to liquid, then to gas, right? So this is increasing temperature. Next, okay, melting point will be always lower than boiling point. Okay, and when a substance is at a temperature below its melting point, it is a solid. When a substance is at the temperature between its melting and boiling point, it is a liquid. And finally, when a substance is at a temperature above its boiling point, it will be gas. So for this question, right, how I would approach it is I will first check whether these temperatures here, are they in between minus 183 to minus 220 degrees Celsius, to make sure that oxygen is a liquid. Once I know that, okay, oxygen is a liquid, then I'll check whether the rest aren't liquid, because I only want oxygen to be a liquid. Okay, so this is how I'll approach it to simplify my answer. So now let's start off with oxygen. Okay, so the melting point of oxygen is negative 220 degrees Celsius. Okay, and the boiling point of oxygen is negative 183 degrees Celsius. Okay, remember minus 220 is smaller than negative 183. Okay, the more negative a number, the smaller it is. The more negative the temperature, the colder it is. Okay, now coming back to this, based on these values here, we know that oxygen will be a liquid at a temperature between negative 183 to negative 220 degrees Celsius. So now at minus 180 degrees Celsius, minus 180 is bigger than, so here's minus 180 degrees, right? So at minus 180 degrees Celsius, it is not in between minus 220 and minus 183 degrees Celsius. So, and it is higher than minus 183. So in other words, right, oxygen is a gas at this temperature. So I will eliminate A. Okay. Then if you were to check minus 185, so minus 185 is here, minus 188, and minus 200, they are all in between the melting and boiling point of oxygen. So therefore, okay, oxygen will be a liquid at these three other temperatures. Okay, so based on checking oxygen, we know that oxygen is a liquid, okay, from at minus 185, minus 188, and minus 200 degrees Celsius, because these temperatures, right, are in between minus 183 to minus 222 degrees Celsius. When the temperature is in between the melting and the boiling point, a substance is in the liquid state. Okay, so now that we have found that, okay, oxygen is liquid for option B, C, and D, we need to check to make sure that argon and nitrogens are not liquid, so that we can use that as the answer. Right. So now let's take a look at this. So I will start off by using nitrogen. Okay, so let me erase this. Okay, and I'm going to do so for nitrogen now. So, nitrogen. So temperature, I'll use it as degree T. So now nitrogen has a boiling point of negative 197 degrees and a melting point of negative 210 degrees Celsius. So in order for it to be a liquid, it must be in between minus 197 to minus 210. Anything out of it, it is either a liquid or gas. If it's above minus 197, it is a gas because it has boiled. If it's below minus 210, it is a solid because it has freezed. So minus 185 is here. So nitrogen is a gas, so okay, it is a gas, so we can still use option B. For option C, minus 188 is here, so nitrogen is also a gas, so we can still use this option. Minus 200 is here, so nitrogen is a liquid, okay, at minus 200 degrees Celsius, but we do not want, okay, to use but we do not want it to be a liquid, right? We want only oxygen to be the liquid. So option D is out. Okay, so now we are left with option B and C. So let's take a look at argon now. So we do not want argon to be a liquid. It can be a solid or gas, right? So if you look at argon, its melting point is minus 190 degrees Celsius. And its boiling point is negative 187 degrees Celsius. So anything in between minus 190 and minus 187, it is a liquid. So we do not want that. We want it to be either greater than negative 187 or smaller than negative 185, right? So or smaller than negative 190. So at minus 185 degrees Celsius, it is here. Okay, so it is a temperature greater than the boiling point of argon, so argon will be a gas. So this is correct because argon and nitrogen are not liquids, only oxygen is a liquid. So option B is the answer. But before I eliminate that, let's see why C is wrong. So at minus 188 degrees Celsius, okay, it is in between the melting point as well as the boiling point of argon. So argon will be a liquid. So therefore C is out. So therefore the answer for question 4 is B. Okay, next let's move on to question 5. Deuterium is an isotope of hydrogen with a nucleon number of 2. Nucleon number means proton plus neutrons. Okay, and it is an isotope of hydrogen. So if you take a look at hydrogen, okay, here, so we know that hydrogen has 1 proton, right? Okay, the proton number will always remain the same. Okay, the proton or atomic number will always remain the same, doesn't matter what isotope it is. So you can always use these numbers on top or the proton or atomic number when we are looking at isotopes. Only the bottom number, which is the relative atomic mass, might not be the same. So we know that hydrogen has one proton. So deuterium, which is also an isotope of hydrogen, will have 1 proton. Since it has a nucleon number of 2, nucleon number refers to the number of neutrons plus protons. Okay, so we know that it also has 1 neutron, so that the number of proton plus neutron is equals to 2. Okay, next, heavy water D2O is water in which both the hydrogen atoms have been replaced with deuterium. It is commonly used in nuclear reactions. Some properties of ordinary water and heavy water are shown. Okay, which process can be used to recover heavy water from ordinary water? So let's look at how to recover them. So cracking is only to break. It's a process where your large alkanes break down to form smaller hydrocarbons. It is not used for water, so it is out. Fractional distillation is used to separate substances with different boiling point, and yes, we notice a different boiling point for both substances. So yes, it is. Okay. Separating funnel is used to separate substances that are immiscible. Okay, so water will dissolve in water, right? It will form one single layer. You will not have 2 layers. You will not be able to get 2 layers of water. So this will not be possible because the D2O and the H2O, they will mix together to form one single water. Okay, so therefore separating funnel is not possible. I know they have different density, right? But if they have different density but they mix together to form a uniform substance, you cannot use a separating funnel. Okay, simple distillation is to separate the solvent from the solute. So there's no solute, right? There's no salt. You're just separating ordinary water from heavy water, so it is out. So the only answer that you can get, so the only correct way of separating water from deuterium is fractional distillation. Question 6. The diagram below can be used to illustrate the following: pure elements, a mixture of elements, a pure compound, a mixture of elements, and a compound. Okay, so next let's take a look at pure element. If you look at this, this is definitely a pure element because each molecule is made of the same size or a same type of atom. So same type. So this is an element. So this is definitely element. So W is an element. So A and C are correct. Let's look at Z. Z is definitely not. You have compound is a mixture. You see this and this, they are different, right? So when you have many different types of compounds or elements mixed together, is a mixture. So Z is out. Okay, X is a compound because 2 different types of elements make up a molecule. So X is also out. So we are left with option A and option C, right? Okay, so now let's go on to a mixture of elements. So if you look at this, Y is a mixture of elements. You have one type of element, which is the square, and one type of element, which is the circle. The circle is by itself, so it's an element. The square is by itself, so it's an element. So you have 2 types of elements present. Next, a pure compound. So X is a pure compound because if you look at each molecule, it's made up of these 2 types of elements. And you only have this, a circle and a oval shape joined together. So you only have this type of compound present. So therefore, X is a compound. And a mixture of elements and compound, we talked about it already, is Z. So therefore, the answer for question 6 is C. Moving on to question 7, an element M has protons, P protons and N neutrons in its nucleus. Which row gives the correct number of protons, neutrons, and electrons in a positive ion of an isotope of M? So what is an isotope? Isotope will have the same number of protons. So the number of protons must still be P. Okay? If it forms an ions, nothing happens to the number of protons. It is only the number of electrons that has changed. So we can straight away eliminate C and D. Okay? Next, we need to have isotopes. So isotopes are atoms, okay, with the same proton number but different number of neutrons. So it needs to have a different number of neutrons. If not, it is the same. It is not an isotope, right? So straight away, we are left with A and B. A has N neutrons. So it is exactly the same, right, as M, right? It's not an isotope of M. So A is out. We are left with B. But before I go on to the next question, I'll explain why the number of electrons is correct. So next, we have a positive ion of positive ion. So for positive ion, you have more protons than electrons. So the number of electrons must be less than P. So P minus 1 is lesser than P. So therefore, you'll form a positively charged ion with a charge of plus 1 because there's one more proton than electrons. Okay, so B is the answer. Next, let's move on to A. The atomic structure of two elements Q and R are shown. What is the mass of 1 mole of the compound formed between Q and R? Okay, so before we can find the mass, okay, we first need to find what is the formula. So if you look at atom Q, it has 1 valence electron. So in other words, atom Q is in group 1. If you look at atom R, it has 1, 2, 3, 4, 5, 6. It has 6 valence electrons. So it's in group 6. So we know that group 1 forms an ion with a charge of plus 1 and group 6 forms an ion with a charge of minus 2. Right? So you have Q plus and R2 minus. So what is the formula? It will be Q2R. Alright? So the formula of the compound is Q2R. So now that we know that this is its formula of Q2R, what is the mass of 1 mole? Well, mass of 1 mole is equals to molar mass, which is going to give the same value as your relative molecular mass. Okay, so to find relative molecular mass, we need to have your, look at here, oops. You need your relative atomic mass. To find relative atomic mass, you can simply take your protons plus neutrons. Okay, so for Q, its relative atomic mass is 7. For R, its relative atomic mass is 18. So to find 1 mole of Q2R, it will be equals to 7 times 2, because there are 2 Qs, plus 18. Okay, so which is 14 plus 18, which gives us 32. Okay, so the mass of 1 mole of the compound formed between Q and R, which is Q2R, is 32. So the answer is C. Moving on to question 9. In which molecule are all the valence electrons of the atoms involved in bonding? So all the electrons need to be used for the bonding. Okay. So if you look at CH4, so C has 4 valence electrons, right? I'll just draw out the valence electrons. H has 1 electron. It also has 1 valence electron. It basically just has 1 electron. So you notice for CH4, all the electrons are used for bonding. So the answer for 9 is A. Okay, but I'll go on to explain why B, C, and D are wrong. So if you're interested, let's go through them. Okay, so we have H and F. F is fluorine. Fluorine is in group 7. So I'll first draw out 7 electrons. 1, 2, 3, 4, 5, 6, 7. H is in group 1. Okay, so you notice that all of H valence electrons are used for bonding, but for fluorine, it has 2, 4, 6 electrons that are not used for bonding. Okay, 6 of its valence electrons are not used for bonding. So therefore, B is not the answer. Next, let's move on to water. So water, so we have oxygen that is in group 6. So let's draw out 1, 2, 3, 4, 5, 6. Okay, 6 electrons. So we have 2 hydrogens. So 1 hydrogen is put here. The other hydrogen is put here. So you notice only 2 out of the 6 valence electrons of oxygen are used for the bonding. So therefore, we can say that C is not the answer. Next, NH3. So nitrogen is in group 5, so I'll draw out 5 electrons. 1, 2, 3, 4, 5. There are 3 hydrogens, 1, okay, and they will bond to nitrogen. So if you look at this dot and cross diagram of NH3 here, you notice only 3 out of the 5 electrons are used for bonding. So, 3 out of the 5 valence electrons are used for bonding. So therefore, not all of the valence electrons are used for bonding. So therefore, D is not the answer. Moving on to question 10, J, K, and L are 3 different elements in the periodic table. The electronic structure of the compound formed between J, K, and L with only the valence electrons is shown here. So J, K, and L. Okay. Which statement is correct? So J belongs to group 2, very likely, because it forms a cation with a charge of +2. So J belongs to group 2. Agree. Okay. Next, element K could be nitrogen. So let's look at K here. So it has 1, 2, 3, 4, 5. Okay, how do I know that these electrons are not from K? If you look at this, the cross are the electrons of J, right? Then for K, okay, is electrons. Let's don't look at this because these 2 electrons, one is from K, one is from L. So we can't tell whether it is the black oval that belongs to K or the white oval that belongs to K. So we look outside. So you have both the black ovals and the cross. So the cross tells us that it is K that has gained electrons from J, right? Because from here we know that the cross are the electrons originally from J. So in other words, we know that these are the electrons of K. And from here, we can deduce that the white circle refers to the electron of L. Okay, next thing, we know that K will not lose electrons because it forms anions, right? KL forms anions. So they don't lose electrons, they gain electrons. And we already know that it has gained 2 electrons from J, which is represented by these 2 cross. So in other words, right, all these black electrons here are the original valence electrons of K. So let's count 1, 2, 3, 4, 5. So K has 5 valence electrons. Okay, so it has 5 valence electrons. So its atom has 5 valence electrons. So it is from group 5. So let's check whether nitrogen is in group 5. All right. So yes, nitrogen is in group 5. It has 5 valence electrons. So B is possible. Okay, next, let's take a look at C. Element K and element L are bound together by a covalent bond. Yes, this is the covalent bond because they share electrons. So C is correct. L is a metal. No, we know that L only has 1 electron, right? 1 electron. Okay, and looking at the periodic table, if its atom only has 1 electron, that means it has only 1 proton. So it's hydrogen. So hydrogen is not a matter, it's a non-matter. So therefore D is wrong. So the answer for 10 is D. Let's move on to question 11. So in question 11, we are told that 5 solutions were prepared so that each solution contains 1 mole per dm³ of the following ions, Fe2+, Fe3+, and so on. To each solution, excess aqueous ammonia was added and the precipitate, if any, was filtered and weighed. The masses were obtained and plotted on the bar graph. So look at this. Very likely, we know that very likely it has something to do with QA. Okay? Now, if we add aqueous ammonia, okay, we are going to precipitate out the hydroxide ions. Okay? So basically what we are looking at is the iron 2 hydroxide, iron 3 hydroxide, sodium hydroxide, zinc hydroxide, and copper 2 hydroxide. Okay, and we are going to add excess. So recall in your QA chapter, some of them, the precipitate is soluble in excess aqueous ammonia, right? So later on, it will dissolve, then the mass of the precipitate will go to 0 because it's soluble in excess equals ammonia, and we have added excess. Okay, so which of the following shows the correct graph? So the first thing we need to do is to recall your QA table. Okay, so because we know that only those elements, right, where the precipitate is insoluble in excess will remain. Okay, so if it is soluble in excess, okay, soluble in excess equals ammonia, there will be no more precipitate at the end of the day. But if it's insoluble in excess equals ammonia, it will still have a precipitate. So it will still have a mass, because this mass refers to the mass of the precipitate. Okay, so now let's take a look at the QA for cations, which you need to remember for your O-level chemistry. So let's take a look at this website here. So I'll provide you the link in the description, okay, where to see this one. So if you have to look at this, we do have iron 2, iron 3, sodium, zinc, and copper. We know that sodium definitely won't have any precipitate. Reason is because sodium is a highly soluble, so sodium hydroxide is also soluble. Okay, so there will not be any precipitate at all. So here should be empty. So B is out, D is also out, because Na plus should be empty. There will not be any precipitate. Okay, so next let's check Fe2 plus, Fe3 plus, zinc, and copper. Okay, so let's look here. Fe2 plus, Fe3 plus, okay, they both form precipitate that is insoluble in excess equals ammonia. So at the end of the day, you'll still have some precipitate left. Okay, for zinc, okay, in the presence of excess equals ammonia, okay, the white precipitate that is formed will dissolve. So you have no precipitate for Zn2+. How about Cu2+? For Cu2+, in the presence of aqueous ammonia, it will form a white light blue precipitate, and it is soluble in excess. So because it is soluble in excess, at the end of the day, you will have no more precipitate. So in other words, for Cu2+ and for Zn2+, there will not be any precipitate when you add excess aqueous ammonia. Only Fe2+ and Fe3+ have excess will have precipitate when you add excess aqueous ammonia, because these precipitates here are insoluble in excess aqueous ammonia. Alright, so let's go back to here. So we know that Zn2+ and Cu2+ will also not have any precipitate, so it's 0, 0, 0. So the answer for 11 is A. Okay, let's take a look at question 12. So in question 12, we are told that a concentrated aqueous solution of a strong acid HX contains molecules of water and the ions H plus and X minus. Which statement is correct? So the pH value of the acid is above 7. No. For acid, the pH is below 7. The solution also contains a high concentration of water molecule. It's a concentrated aqueous solution of strong acid. So you have a high concentration of acid, a low concentration of water. So not necessarily true. The solution also contains OH minus ions. Yes, this is true, because although it is a concentrated solution, you still have water, and there is a partial dissociation of water to give H plus and OH minus. So there's still some H plus and OH minus, and the OH minus comes from the water. So C is correct. Okay, so C is the answer. Next, D, the solution contains less H plus ions than water molecules. It is a concentrated solution, so very likely it has more H plus than water molecules. Okay. Next, let's move on to question 13. Two reagent bottles contain solutions of ammonium nitrate and ammonium carbonate respectively. The labels have fallen off. Which substance can be added to each bottle to identify the reagents correctly? So basically, you have ammonium nitrate and ammonium carbonate, and you need to determine which one is which one. And both of them have ammonium. So in other words, you need to do a test to test for nitrate or carbonate. Okay, so we are going to test for either nitrate or carbonate. Okay, and this is basically a QA chapter, so you need to remember how to test for the different cations and anions and gases for your O-level chemistry exam. So let's take a look at testing of anions. I'll provide the link to this page, okay, in the description below if you are interested. So coming back to this, so we look at carbonate and also nitrate. So in order to test for carbonate, you add acid. If effervescence of carbon dioxide is produced, then you will, we can say that yes, this is carbonate. In order to test for nitrate, you need to add sodium hydroxide and aluminum foil and warm carefully. If ammonia is produced, then it will be nitrate. Okay, but there's a trick to this question. I'll talk more about it later. So let's go back to the question now. Okay, let's go back to the question here. Okay, so now if you to take a look at this, right, you know that, okay, nitrate, you add aqueous sodium hydroxide and you need aluminum foil, right? There's no aluminum foil. So actually, this D is out, okay? So you cannot test with this, you cannot test with this. The only option is add a nitric acid, which is an acid. So the acid will produce carbon dioxide, okay, with ammonium carbonate, but not with ammonium nitrate. Okay, so the answer is B. So take note, right, if they change the option of question 13 to aqueous sodium hydroxide with aluminum foil and heat, you still need to say these still cannot be used. Okay, reason is because, right, okay, although this is used to test for nitrate, once you add sodium hydroxide and heat, okay, your ammonium will give ammonia gas. It doesn't need an aluminum foil. So if it doesn't need an aluminum foil, okay, okay, let me show you. So let's take a look at here. So if you look at ammonium, okay, if you add sodium hydroxide and heat it, you'll get ammonia gas. For nitrate, you add sodium hydroxide, then add aluminum foil, then warm, you get ammonia gas. So in other words, right, if you have ammonium, if you want to test for ammonia, or if ammonia is present and you add aqueous sodium hydroxide and you add aluminum foil and you warm, it will also produce ammonia gas. Okay, because you don't need aluminum foil, you just need sodium hydroxide and warm to give ammonia gas, right, if you have ammonium ions. So whether you put aluminum foil or not, it will also produce ammonia gas. So for this question, right, if option D is changed to aqueous sodium hydroxide with aluminum foil and heat, okay, you still need to eliminate it because the ammonium ion will produce ammonia gas and both of them contain ammonium ions. Okay, so whether you have aluminum foil or not, these two, when you heat it with sodium hydroxide, they will give out ammonia gas and you cannot distinguish them. Alright, so the only way to distinguish between ammonium nitrate and ammonium carbonate, because they both have ammonium, okay, is to use nitric acid. Okay, moving on to question 14. Z is a solid which conducts electricity. Solid, so it is a matter, right? Because ionic compounds, they only conduct electricity at in molten state or when dissolved in aqueous solution, not in solid. So we know that to conduct electricity in solid state, it must be a matter. Has a high melting point. Metals have a rather high melting point. On warming, Z, so in other words, right, we can eliminate sodium chloride already. Graphite also can conduct electricity. Okay, it can conduct electricity because of the mobile electrons. Okay, it's not a matter. Okay, you can also have graphite. All right. It also has a relatively high boiling point, so we won't eliminate B yet. On warming, Z partially dissolves in excess dilute nitric acid, leaving behind a residue. Okay, what is the likely identity of Z? So on warming, okay, it dissolves partially in nitric acid. So in other words, right, it is a metal. So we know graphite is out already because graphite will not react with acid. Okay, so we have metal reacting with acid, right, and leaves behind a residue. So we know zinc will react with acid. It will form a zinc salt, right, and hydrogen gas is produced. So all the zinc will go into the solution. It will not give any residue. Okay, so D is not the answer, and based on this, the answer is going to be A. So why is it A? So first, before we can do that, we first need to see what is brass made out of. Okay, so what are the main metals in brass? So for this, you need to remember that brass is composed of copper and zinc. So it's an alloy with copper plus zinc, right? So we know that all the zinc will react with acid, okay, and to form a salt which is dissolved. Okay, but copper is below hydrogen in the reactivity series. So because copper is below hydrogen in the reactivity series, it will not react with the acid. It will still remain behind, and that is why you have a residue. So therefore, the answer for question 14 is A. Okay. Now move on to question 15. Which of these three salts are prepared by precipitation? So in order for a salt to be prepared by precipitation, it must be insoluble. It must be an insoluble salt. So it's basically, remember your solubility table for this chapter. Okay. So barium sulfate is insoluble. All nitrates are soluble. There are no exceptions. So straight away we can eliminate option A and B already because you contain nitrate, because nitrate is soluble, right? So I left with C and D. Calcium carbonate is insoluble. This is true. Barium sulfate is also insoluble. Lead 2 chloride is insoluble. So C is the answer. So why is D wrong? So calcium chloride is soluble. Okay. All chlorides are soluble except for your silver as well as your lead. So calcium chloride is soluble. Okay. Barium sulfate is insoluble. Okay. Silver sulfate is soluble. So therefore, D is eliminated. Your answer is C. Next, let's move on to 16. In an experiment, 2 cm³ of 1 mole per dm³ of aqueous copper 2 nitrate and 4 cm³ of 1 mole per dm³ of aqueous potassium carbonate are mixed. What does the reaction vessel contain once the reaction is complete? So we have CuNO3 2 is added to K2CO3. Okay, it's a salt and a salt. Right, and we have never learned this reaction. It's not an acid-base, acid carbonate, acid metal reaction. So it's a precipitation reaction. Why I know that? Because a lot of carbonates are insoluble. Okay, so you just swap the ions. So this is what you get. So we know that we have 2 cm³ of 1 mole per dm³. So let's find the number of moles. So it will be 0.002 dm³. Sorry. 0.002 dm³ times 1 mole per dm³. So that's 0.002 moles. And then for here, if you calculate, you take 4 over 1000 times 1, you get 0.004 moles. Okay, if you look at the equation that I have already balanced, you'll notice that it is 1 mole of copper 2 nitrate reacts with 1 mole of potassium carbonate. So if, in other words, right, you have excess potassium carbonate. This is in excess. Because I only use 0.002 moles of copper 2 nitrate. So only 0.002 moles of potassium carbonate will react. Okay, so you have this sum of it that is being left. Okay, so we have some of this being left. Okay, this will completely be used up, so no more. So at the end of the day, we have this solid and this solution. So at the end of the day, what we have is potassium carbonate and potassium nitrate solution. Both of them are colorless. So you have a colorless solution. Okay, copper 2 nitrate is gone, so no more copper 2 nitrate. You have copper 2 carbonate, which is a green solid. Okay. So in other words, you have a green precipitate and a colorless solution that is being formed. So the answer is C. Okay, let's move on to question 17. Ammonia is used to make nitric acid HNO3 by the Oswald process. 3 reactions occur in the following stages. What is the number of moles of nitric acid produced from the reaction between 50 dm³ of oxygen gas and excess ammonia gas in stage 1? So I know that I have 50 dm³ of oxygen. And you want to find what's the number of moles of nitric acid produced. So it's this one, right? So you use 50 dm³ of oxygen in stage 1. Okay. So I use 50 dm³ of oxygen in stage 1. Okay. I will have So remember, for gas, mole ratio equals to gaseous ratio. So if you look at reaction 1 and reaction 2, right? So reaction 1 forms these. And why do we need reaction 1 before you go to reaction 2? It's because it is linked by this one here. NO, right? The NO form will go on to form NO2. And the NO2 from reaction 2 is linked to reaction 3. The product form is used for the third reaction. Okay, so why I highlight this is because you are interested to find how much we have for this, because they will link it to the next reaction. Okay, so I know there's 50 cm cube of 50 dm cube of let me highlight this first. 50 dm cube of oxygen. So because I know there's 50 dm cube, I'll use it to find NO. So gas ratio is equals to, mole ratio is equals to volume ratio for gases at the same temperature and pressure. So we know that the number of moles of NO will be, the volume will be 40 dm cube here. So because I form 40 dm cube here, will also be 40 dm cube. Okay, don't be confused by the mole ratio. The mole ratio, the 4 and the 2 here, has no significance to each other because they are different reactions. Okay, but we know that whatever is formed here is used for the next reaction. So if there's 40 dm cube of NO being formed, the 40 dm cube of NO that is being formed will be used for reaction 2. So 40 dm cube of NO formed, okay, because the mole ratio of NO to NO2 is 2:2. So if you have 40 dm cube of NO, you also have 40 dm cube of NO2. Okay, so now we have reached here is 40 dm cube of NO2. So let's find the number of moles of NO2. Okay, so it's 24 moles. Okay, so type it into the calculator. It gives me 1.67 moles. Okay, based on the mole ratio, this is 3:2. Okay, so because I'm interested in the moles of nitric acid form, right, I'll be looking at this here. So I know 3 moles of NO2 will give 2 moles of HNO3. So if you have 1.67 moles of NO2, it will give 2/3 times 1.67 moles of HNO3. So it gives me 1.11. So based on this, the answer for question 17 is A. Moving on to 18, hydrazine N2H4 is a powerful reducing agent. When reacted with an aqueous solution containing silver ions, nitrogen is one of the products formed. Which ionic equation best represents this reaction? So it is N2H4 is a reducing agent. That means it will reduce other substances. So because it reduces other substances, Ag plus, it cannot have negative charge, right? It's a metal, right? The lowest oxidation state it can go to is Ag, where the oxidation state is 0 and it has no charge. So we know that N2H4 very likely reacts with Ag plus to form Ag. And we also know that nitrogen is one of the product, right? Okay, and we are left with hydrogen. So very likely we also have 2H2 to balance the equation. Correct? No. Okay, in order to write an equation like this, you need 2 things. Firstly, you need to have molecular balance, atomic balance, and secondly, you need to have charge balance. So whenever you write an equation that has a charge, that means it's an ionic equation, you must satisfy 2 things. First, atomic balance. That means it's the same as balancing all chemical equations. The second thing you need to make sure is the charge is balanced. So if you have a total charge of +1 here, you must have a total charge of +1 on this side as well. Okay, so I cannot write 2H2 because the charge is not balanced. Okay, there's a charge of +1 here. There must also be a charge of +1 here. All right. So now, how do I get a charge of +1? I can't, right? So I know that H definitely won't be H, it will be H plus. And because I have 4H plus, I need to have a charge of +4, right? So I'll need to put 4 here. So based on this, the answer is D. Okay, another way to do this question is to look at the answer options provided. Okay, so you know that N2H4 and Ag plus, okay, will form something, right? So they already tell us that you have N2. So definitely must have N2. So all the answer option has N2. Okay, then we know that N2H4 is a reducing agent. That means it must reduce your silver ions, right? So Ag plus must be reduced. So A is out already because this one is +1. The oxidation state of Ag here is +1. The oxidation state of Ag here is +2, right? This is H2. So when it is bonded to a metal, the hydrogen will have a negative oxidation state. It's a hydride. Okay, so A is out. So you're only left with B and C. So if you look at B and C, B is wrong because this equation, although you balance it, you have atomic balance, you do not have charge balance. Okay. This is also wrong. You also do not have charge balance. The charge here on the reactant side is +1. The charge here on the reactant side is +4. Not balanced. So therefore the answer is D. Okay. So this question, right, it actually tests you not only on what is a reducing agent, it also tests you on writing of ionic equation. In order for you to write a balanced equation, and when it has ions, you need to achieve two things. One of it is atomic balance and the other one is charge balance. Next, moving on to question 19, dilute ethanolic acid was titrated against sodium hydroxide. The pH change was recorded using a pH meter. The graph of pH against volume of alkali added was plotted as shown. The diagram shows the pH of 3 indicators. Which indicator can be used to determine the endpoint of the titration? So you know that at this point here, at the endpoint, which is when you add 25 cm³ of alkali, there is a big jump in the pH. Okay, and the pH change from close to 7 to around 12 to 13, 12. Okay, so in other words, right, the indicator that you use, right, must have a color change between 7 to 12, a pH of 7 to 12. Okay, so if I change color when it goes from 7 to 12. So if you look at the methyl orange, okay, it changed color at 3. So it changed color here. So it changed from red to yellow here already. And this is not the end point, right? Here, 25 cm³ is the end point. So methyl orange cannot be used. Let's take a look at phenolphthalein. It changes color at around 8.5, which is around here. So it changes color when there is a sharp change in pH, okay, for the titration mixture. So yes, phenolphthalein can be used. Similarly, for bromo talmo blue, this is 6.5. So at 6.5, which is here, it changes color. And that is not the end point yet, right? So it cannot be used. So the only option is phenolphthalein, which is option B. Question 20. Some properties of metal H are listed. It does not react with cold water. So in other words, it is not a group 1 metal. So potassium is out. H reacts with dilute hydrochloric acid, so it must be above hydrogen in the reactivity series. So copper is out because copper is below hydrogen in the reactivity series, so it will not react with acid. No reaction occurs when the oxide of H is heated with carbon. So it tells us that, right, the metal is reactive enough, okay, such that it cannot be reduced by heating with a reducing agent. So we know that iron oxide can be reduced by heating with reducing agent. Okay, remember your blast furnace for the extraction of iron from hematite. It is basically heating your oxide with carbon monoxide, right? If it can react with carbon monoxide, it can be reduced by carbon monoxide. Very likely it can be reduced by heating with carbon. So B is out. So the answer is C, magnesium. Magnesium is a reactive metal, so its oxide cannot be it cannot be extracted from its oxide by heating with a reducing agent. In order to extract magnesium, you need to use electrolysis of it. Yeah, electrolysis of its molten oxide. Moving on to question 21, 10 cm³ of propane is burned in 70 cm³ of oxygen in closed container. What is the total volume of gas present after the reaction at room temperature and pressure? So we start off with 10 cm³. So if you have 10 cm³ of propane, you need 50 cm³ of oxygen, right? But how many cm³ of oxygen did we use? We used 70. So in other words, oxygen is in excess. And how many cm³ is it in excess? It has 20 cm³ of excess oxygen. And this 20 cm³ of excess oxygen will be left at the end of the reaction. So we know that at the end of the day, we have 20 cm³ of oxygen. Next, let's look at the volume of CO2 formed. It will be 30 cm³. Water is a liquid, so we'll ignore it because they only ask us for the total volume of gas present. So we know that 30 cm³ of carbon dioxide is produced, 20 cm³ of oxygen is left. So total, we have 50 cm³ of gas that is present after the reaction is complete. So the answer is B. When a mixture of sodium chloride and sodium hydrogen carbonate is heated, the following reaction takes place. Okay, so sodium chloride is very stable to heat, nothing happens. But if you heat sodium hydrogen carbonate, this is what happens. Okay, sodium chloride is unchanged on heating. So when 6 grams of the mixture is heated, the loss in mass is 1.5 gram. What is the percentage by mass of sodium hydrogen carbonate in the mixture? Okay, so now the loss in mass is 1.5 gram. Why is there a loss in mass? Because the water and the carbon dioxide has been lost. Okay, it's given out. So we know that mass of CO2 and H2O produced, okay, is 1.5 grams. Okay, I do not know how many moles, but if I know that if there's X moles of CO2 produced, there will also be X moles of H2O produced, because the mole ratio here from the equation is 1:1. Okay, so what I can do is I can let the number of moles of CO2 be X. So the mass of CO2 produced will be equals to molar mass, which is 44 times X. Okay, so mass of CO2 will be 44x, and mass of H2O produced will be 18x. And I know this 18x plus 44x is equals to 1.5 grams, right? So from there, I can find the number of moles of CO2 or H2O produced already. So it's 0.0242. 0.0242. So I know that 0.0242 moles of CO2, 0.0242 moles of H2O being produced. So if you look at the mole ratio, the number of moles of NaHCO3 will be 2 times 0.0242, which is equal to 0.0484 moles. So the mass of NaHCO3 is basically equals to the number of moles, which is 0.0484, multiplied by its MR, which is given here, 84. Okay. Which is 4.06 grams. 4.06 grams. Okay, and I know that the total mass of sodium chloride and sodium hydrogen carbonate is 6 grams. So from here, what did they ask? Okay, what is the percentage mass of sodium hydrogen carbonate? So I don't need to find the mass of sodium chloride. So percentage NaHCO3 is essentially this 4.06 divided by 6 grams times 100%. Okay. Which is around 68% when rounded off to two significant figures. I round off to two significant figures because all the answers are two significant figures or the nearest whole number. So therefore the answer for question 22 is C. Moving on to question 23. So in question 23, these statements refers to hydrogen and is used as a fuel. So both water and hydrocarbons can be used as a source of hydrogen. Okay. Water cannot be yes, so this is true. So it's basically remembering a hydrogen fuel. So in the fuel cell, hydrogen reacts with oxygen to generate electricity. So in the fuel cell, the hydrogen does not react with oxygen to generate electricity. Instead, they are the one that is being produced. The reaction taking place in the fuel cell is a redox reaction. Yes, it is. Okay, so because it's an electrolysis, so it's a fuel cell reaction. Fuel cell reaction or your electrochemical cell, they're all redox reactions. So 1 and 3 are correct, so the answer is B. Moving on to question 24, P, Q, R, and S are found to have the following properties. Only oxides P and R can be reduced by heating with hydrogen. Okay, P and so in other words, right, it is not a reactive matter. Okay, because so P and R, they can be reduced by heating with with hydrogen. So P and R, they are less reactive. Those that cannot be formed by heat, whose oxide cannot be reduced by heating with reducing agents such as hydrogen, carbon monoxide, they are more reactive. So Q and S are more reactive. Okay, next, P and Q react with acid but not with cold water. So P and Q react with acid but not with cold water. Okay, R does not react with both acid and water, so I know that R is the least reactive already. And P is slightly less reactive than it. Okay, then I know that Q can react with acid but not with cold water, so it just tells me that it's not a reactive matter. Carbonate of S does not decompose under heat, so that means it is a group 1 carbonate, right? That's why it doesn't decompose under heat. Okay, and group 1 reacts with cold water, they are very reactive, but Q cannot. That means Q is less reactive than S. So the order is S, Q, P, R, S, Q, P, R. So the answer is C for 24. Question 25, which diagram shows the structure of an alloy? An alloy is a mixture of metal. So this is out, this is diamond, this is out, this is graphite, this is out, this is pure metal, because the size of all the atoms are the same. So the answer is D. Okay, because you have a different size of atom here, that means it's a mixture. So it's a metal plus something else, an atom of another element. So it's a mixture, so therefore it's an alloy. Question 26. Some reactions of element M are shown. So you have element M, you burn, you form an oxide, you add water, you get a solution. The solution, you add blue litmus, it turns red. Turns red. So what does it suggest? It is acidic. So it's an acidic oxide. So in other words, to form acidic oxide, M is a non-metal. Okay, so because it's a non-metal, let me eliminate all the metals here. Okay, I'm left with carbon and sulfur. So next, I add to purple potassium manganate. You have purple solution turns colorless. So if I add burn, I get CO, CO2, but I know it's not CO because I need it to be acidic. Carbon monoxide is not acidic, it's also not soluble in water. Okay, if it is sulfur, I'll have SO2. So carbon dioxide and sulfur dioxide, which one is the one that can decolorize purple potassium manganate? It is sulfur dioxide. Okay, so the answer is D. Question 27. This proportionation is a reaction in which the same element is oxidized and reduced simultaneously. Which reaction is an example of this proportionation? So you need the same substance to be oxidized and reduced simultaneously in order for it to be a disproportionation reaction. Okay, even before doing something, I will cancel off B. Reason is because all precipitation reactions and all acid-base reactions are not redox reactions. So KOH is an alkali, H2SO4 is an acid-base reaction, not redox. If there's no redox, there's no change in oxidation state, you will not have something that's being oxidized or reduced. Okay, so B is out. So we only need to look at A, C, and D. Alright, so now let's take a look at this. So maybe I'll start off with copper. So copper's oxidation state is 0. So copper will never have a negative oxidation state. right? So you know that Cu only forms this, which is Cu2 plus, okay? So you can ignore it. So in order for a disproportionation reaction to occur, right, the one of the element must form two different substances. So Cu shouldn't be the one that I consider. I'll consider N, because you notice I start off with HNO3 and I form two compounds that contains N. So let's calculate the oxidation state of N in HNO3. So HNO3, so each oxygen has an oxidation state of -2, so 3 of them is -6. 1H is +1, so total oxidation state add out to be 0, so N must be +5 here, so that everything add out to be 0. Again, nitrate and nitrate, they must have the same oxidation state, or you can still calculate it, it's the same. This one is O is -2, so this N is +2, so it is reduction. So you only have reduction, you do not have oxidation, so A is not the answer. Next, let's move on to C. So you have nitrogen. So I'll consider nitrogen because it forms two different things. Right? I won't consider O and H because I know that unless you have element, the oxidation state of O will always be -2 unless you have O2 or O3. Okay, same thing for hydrogen. Unless you're looking at element, okay, the oxidation state of hydrogen will always be +1. Oh, but there's an exception. If it is directly bonded to reactive metals, there is a hydride. Okay, then it's -1. Okay, so coming back to here, right? So we look at this. The oxidation state of this N here is +4 because one oxygen has an oxidation state of -2, two of them -4, so this will be +4. Nitrate, by now you'll be very familiar, is +5. HNO2, so let's take a look at this. This H is +1, two oxygen. One oxygen has an oxidation state of -2, two of them is -4. So this one is +3 here. So you know that this nitrogen's oxidation state, okay, changes from +4 to +5, which is oxidation, and +4 to +3, which is reduction. So yes, this nitrogen here undergoes disproportionation because it's both oxidized as well as reduced. So C is the answer. Let's take a look at D. D, straight away I'll eliminate it because, okay, in order to have a disproportionation, one of the elements must split into two different types of product, right? So if you look at this N goes on to form two things. If you look at here, the only thing that splits into many different components is your oxygen, right? So if you look at this, here is -2. The oxidation state of O is -2. Here is -2. Here is -2. Here is 0. Okay, there's only one change, right? It is only oxidation for oxygen. So oxygen is out. Then if you look at lead, it only forms one product. So it cannot disproportionate, right? Because the disproportionate, you must form two compounds with two different oxidation states. If you still only form one, it will not be disproportionated. Okay, same thing for N, nitrogen. It only goes on to form one product. Only one product contains nitrogen. So there will be no disproportionation, right? Moving on to question 28. So in question 28, a student wrote 4 statements about the following reactions. So which statement is correct? Complete combustion is involved in the process. So if you look at this, you have TiCl4 plus O2, you get TiO2 and 2Cl2. Okay, so it says that complete combustion is involved in this process. Did everything get burnt? So Ti forms TiO2. Cl forms, what did it form? It formed an element. Doesn't seem like combustion, right? If you have hydrocarbon, the carbon will go on to form CO2. The hydrogen will go on to form H2O, which is like an oxide of hydrogen. Water is an oxide of hydrogen. Okay, during complete combustion, but not this. So A is incorrect, right? Okay, so A is incorrect. Now let's move on to the second sentence. Energy is absorbed when the bonds are broken in titanium 4 chloride and oxygen gas. Yes, so in TiCl4, which is titanium 4 chloride and oxygen gas, they are the reactants. So in the reactants, what happens is the bonds are broken, right? So the bonds are broken and energy needs to be absorbed when bonds are broken. So B is correct. C, the energy the reaction releases energy and is an exothermic reaction. This is also correct because delta H is negative. So if delta H is negative, we know that it is exothermic and it releases energy to the surrounding. D, the volume of gas produced after the reaction is twice the original volume. So if you look at, if you are interested in the volume of gas, we look at the number of moles of gas. Okay, so for the reactant side, we only have O2 as the gas, and there is 1 mole of O2 in this equation. In the product side, only the Cl2 is a gas, TiO2 is a solid, so we don't consider it. So the number of moles of Cl2 formed is 2 moles. So in other words, if we look at this equation here, we know that 1 mole of O2, okay, will react with TiCl4 to form 2 moles of Cl2. So in other words, right, the volume of gas produced after the reaction is twice its original value. This is correct. So in other words, the only statement that is incorrect is A. Next, moving on to question 28. So in question 28, we are told that the electrolysis of brine, which is concentrated sodium chloride solution, is shown in the diagram below. What are products X and Y? So let's first look at X. X is here, so, and X is a gas, and Y is a solution, right? So it's something that is aqueous, okay, because we tap Y from here. And if you look at both here, this is the negative electrode. That means this is the cation, the cathode, and the cathode is positively, sorry, the cathode, this is the cathode. So in other words, it will attract cations, so the positively charged ion. So now let's look at concentrated sodium chloride. So concentrated sodium chloride, so it contains a bit of water and a lot of NaCl. So the ions present are Na+, Cl-, H+, and OH-. Okay, so we know that whenever you have something that is concentrated and you have a halide, that is your Cl-, Br-, I-, and so on, they will be preferentially discharged, okay, instead of OH- when it is concentrated. So we know that at the anode, which is here, the positive electrode, chlorine gas is produced. Okay, then at the cathode, okay, we have these two ions. So we know that Cl- is discharged, so I cancel it away. Then at the cathode, right, I have this, which is, I have Na+ and H+ that will drift to the cathode, which is negatively charged. Okay, and because H is below Na in the reactivity series, it is preferentially discharged. So H+ will form H2, so the gas X is H2. So I'll eliminate C and D. So now I know that hydrogen gas is produced, okay, so it will get rid of H+, right, because it forms H2. So as time goes by, okay, the solution will be essentially sodium hydroxide. Okay, so the answer is B. Okay, you might be wondering, why is it not just Na+? Why is it NaOH? Just think of it as it's a solution, okay? They are mixed together. Whereas gas, we separate them, okay, with this porous, so this porous walls, right, this gas will not pass through, it just go out. Okay, but for the solution, right, you cannot have a Na+ without an OH-. You have both the cation and ion. Okay, you do not have just a positively charged cation inside the solution. Alright, so therefore you have sodium hydroxide as the solution. Okay, now moving on to question 30. In an electrolysis experiment, the same amount of charge deposited, 38.4 grams of copper and 14.4 grams of titanium. So if the same amount of charge means the same number of moles of electrons. Same number of moles of electrons. So in other words, you need to find the number of moles of electrons for this question. Okay, the charge on the copper is 2+, and titanium has a relative atomic mass of 48. What's the relative charge of titanium? Okay, so we know that it's going to deposit copper, right? So Cu2 plus 2E, it forms Cu. Okay, and we actually form 38.4 grams of copper. Okay, I do not know what is the charge of titanium. Let's assume that it is X plus, okay, plus X. It will form titanium, right? Okay, and we know that the number of moles of electrons involved in the copper reaction and the titanium reaction are the same because the same amount of charge is used. Okay, so now to do so, what we will do is we need to find the number of moles of electrons, and to do so we need to first find the number of moles of copper. So number of moles of copper is equals to 38.4 divided by the AR of copper. Okay, so what's the AR of copper? So from this, I know that it's 64. So over 64. So 38.4 divided by 64 gives me a value of 0.6. So I have 0.6 moles of copper. So from this equation here, I know 2 moles of electrons is needed to form 1 mole of copper. So if there's 0.6 moles of copper, then the number of moles of electrons will be 2 times 0.6, which is 1.2 moles. Okay, next, I know that the number of moles of electrons used in both equations are the same. So here, there's also 1.2 moles. Okay, next, I know that the mass of titanium is 14.4. So let me find the number of moles of titanium by taking mass, which is 14.4 grams, divided by the relative atomic mass, which is 48. Okay, so 14.4 divided by 48, it will give me 0.3. So here's 0.3. So I know that 0.3 moles of titanium will react with 1.2 moles of electrons. So the mole ratio of Ti is to electrons is basically 1 over x, right? Do you agree? So I know 1 over x is equals to 0.3 over 1.2. So therefore, x is equals to 4. So in other words, right, we know that titanium has a charge of plus 4. Okay, so that 1 mole or 0.3 moles of Ti will react with 1.2 moles of electrons, or the mole ratio is 1:4. So the answer is D for question 30. Question 31. So in question 21, a clean dry air is passed over hot copper until all the oxygen in the air reacts with the copper. The volume of the air decreased by 31.5 cm3. What was the starting volume of air? Okay, so we know that the volume of air decreases by 31.5 cm3, and we know that oxygen takes up around 21% of air is oxygen, right? So that means 21% is 31.5 cm3. So to find 100%, we will take 100 over 21 times 31.5. Okay, so type it into the calculator, which gives us a value of 150 cm3. Okay, so the answer is C. Question 32. Which statement about gases in the atmosphere is correct? Carbon monoxide is a pollutant which causes acid rain. This is wrong. Carbon monoxide is toxic, but it is not acidic. It is neutral, in fact. Catalytic converter reduces carbon monoxide to carbon dioxide. Carbon monoxide to carbon dioxide is an oxidation reaction. From CO to CO2, there's a gain in oxygen. It is a oxidation reaction, not reduce, so it's wrong. Methane in the atmosphere depletes the ozone layer. So methane is a greenhouse gas. It increases the temperature. Okay, it doesn't deplete ozone layer. It's your CFC chlorofluorocarbons that depletes the ozone layer. So this is also wrong. D, photosynthesis adds oxygen to the atmosphere. This is correct. During photosynthesis, plants takes in carbon dioxide and gives out oxygen. So D is correct. Question 33. Which noble gas has the highest concentration in dry eye? This is basically memory work. So the highest one is basically argon. Okay. How many of the following statements correctly describe the petroleum gas fraction obtained after fractional distillation of crude oil? Its molecules are hydrocarbons. Yes, this is correct. Its molecules have 1 to 4 carbon atoms. Not necessary. Fixed boiling point, no, is a mixture. It boils over a range of temperatures. The fraction is the same as natural gas? Yes, petroleum gas is the same as natural gas. Okay, so there are two statements that are correct. So the answer is B. Okay, so this is the petroleum gas fraction, or your refinery gas, or your natural gas fractions. Okay. In an oil refinery, petroleum is separated into useful fractions. The diagram shows some of these fractions. What are fractions X, Y, and Z? So this is basically memory work. So Z is the lowest one, is bitumen. Okay, then this layer here after diesel oil is lubricating oil. Okay, then diesel, then you have kerosene, which is used for aircrafts. Okay, then your gasoline and your refinery gas. So the answer is B. So this is basically just memorizing the different fractions of when your petroleum is separated. Okay, moving on to question 36. Which statements are true about alkanes? So the general formula is CnH2n. No. For alkanes, the general formula is CnH2n plus 2. They are flammable. Yes, alkanes are flammable. That's why they are used as fuels. They can undergo combustion reaction. Yes. They react with chlorine only. No. They can react with bromine and so on in the presence of UV light, right? So 2 and 3 are correct. So the answer for 36 is C. The diagram shows a sample of polyethylene. Polyethylene contains molecules with an average molecular mass of 2,800. How many carbon atoms are there in an average molecule of the polymer? So they're asking for how many carbon atoms, right? So we know that basically polyethylene just have this CHH, 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 continuous, continuing, and so on, right? It's continuous. And we know that it only ends somewhere. Okay, so we know that it has this. Okay, for each carbon you have 2 hydrogen. Okay, and carbon has an AR of 12 and 2 hydrogens has an AR of 2, 1 plus 1. So total is 14. So if you want to find how many carbons are there, you just need to find how many CH2 groups there are. So we know that the AR of the molar mass of each CH2 group is 14. So I'll take 2,800 divided by 14, I'll get 200. So therefore, I know that there are 200 CH2 group in this polyethylene molecule, so that it has an average relative molecular mass of 2,800. So if you have 200 CH2 groups, that means you have 200 carbons. So the answer for 37 is C. Question 38. 2 compounds Q and R react together to form a polymer. So if you have a diamine and a dicarboxylic acid, they will react to form a diamide. Okay, they'll form an amide. Okay, a polyamide. Okay, if it's a polymer, you'll form a polyamide. What is the formula of the repeating unit of the polymer? Okay, so to find the repeating unit, what you will do is, okay, you will take H away from this, you'll take OH away from your carboxylic acid, and then you join them together. So what I'll do first is I will first draw Q. This is Q. Then this is R. Okay, so this amine side will lose a H. Okay, then you can form one more bond, right? Then the carboxylic acid part will lose its OH. So it becomes CO. Then it becomes CO this way. So they are asking for the formula, right? So if I were to look at the formula and they just lump everything together, right? It's basically add these two things up. Okay, then minus H2O and minus another H2O. Okay, so basically let's first add out the carbon because they lump everything together. So the easiest way is to add all the carbons because nothing happens to this portion and this portion, right? So I'm going to add out all the carbon and hydrogen in the portion that I've highlighted. Okay, so I know that there are 10 carbons here and 6 carbons here, so it's C16. 10 plus 6 is 16. 20 hydrogens here and 12 hydrogens here. 20 plus 12 is 32. Okay. Next, I have NH. So the NH2 will become NH because they lose a H. Okay. So you have NH and you have two of them. Okay. So this NH2 loses a H. This NH2 loses a H, right? So you have two NH. So NH bracket 2. Next, the COOH will lose an OH. Okay, and you have two of them, so it's CO2. Okay, now I'm going to combine them because they combine all the carbons, right, and the hydrogens together. So I'm going to add two more carbons to here. So 16 plus 2, you have 18 carbons. And here, I know there's two hydrogens, so I'm going to add 2 to this 32, which gives me 34. Then after that, I know that I have two N's and two O's. So the repeating unit is C18H34N2O2. C18H34N2O2. So the answer is B. Okay, so for this, you just need to remember that NH2 portion will lose a H on each side. So each NH2 loses a H. Each COOH loses an OH. Okay, when you form a polyamide from amines, diamines, and dicarboxylic acids. Question 39. Alkanes are saturated compounds containing carbon and hydrogen only. Structure 1, 2, and 3, and 4 are all saturated hydrocarbons. Which pairs are isomers? So firstly, what are isomers? Isomers are basically compounds with the same same molecular formula, different structural formula. So let's first start from molecular formula, see whether they are the same. So I'll start off by counting the number of carbon. 1, 2, 3, 4, 5, 6. So there are 6 carbons here. 1, 2, 3, 4, 5, 6. Also 6 carbons here. 1, 2, 3, 4, 5, 6. 6 carbons here. 1, 2, 3, 4, 5, 6, 7. 7 carbons. So this has 7 carbons. So straight away, it will not be an isomer of the rest because you don't need to count the number of hydrogens. Once the number of carbons is different, okay, then even if you have the same number of hydrogens, which is going to be unlikely because they're all single bonds, okay, you will they are still they don't have the same molecular formula. Not same molecular formulas, don't need to talk about isomerism anymore. Okay, so now three of them have the same number of carbons, right? Now let's take a look at the number of hydrogens. So if basically a simple trick, if they are a straight chain, if they do not have any ring structure, okay, and all are single bonds, okay, then the number of hydrogens, right, will be 2n plus 2, that the number of carbon. So you just need to follow the alkane formula. So it's 14. But let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. This one will also be 14. Okay, because it's an alkane, right, with 6 carbons, right, because there are no double bonds. Okay, so if you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, definitely 14. But this, when you have a ring structure, there will always be 2 less hydrogens than the straight chain. Okay, don't believe, count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12. So 3 has a different formula from 1 and 2. So it cannot be an isomer already because it doesn't have the same molecular formula. And none of them have the same molecular formula as 3, right? So 1 and 2 are likely to be isomers. So let's check, are they the same? So let's look at this. This is basically a straight chain, okay? 1, 2, 3, 4, 5. Okay, and then I branch it on. Okay, if I count here as 1, I branch it on the second carbon. Okay, 1, 2, 3, 4, 5. Then it doesn't matter whether I count from here or count from here. 1, 2, 3. Here will be 1, 2, 3. So I branch on the third. So they have different structural formulas. So therefore, 1 and 2 are isomers. The answer is A. Question 40. A polyunsaturated compound has a molecular formula of 400. Okay, it's unsaturated. Molecular mass 400. 100 grams of the polyunsaturated compound reacts with 127 grams of iodine. Okay, so remember, this is basically your addition reaction with halogens. Okay, so if you have 1 CC double bond, it will react with 1 mole of iodine. Okay, so you react with 1 mole of iodine, then it forms something like this, I and I. Whatever is here remains. Okay, so 1 CC double bond will react with 1 mole of I2. So let's look at the number of moles of the compound. Number of moles of the compound, the polyunsaturated compound, is equals to 100 divided by 400 because we have the mass which is 100 grams and we are given its molecular mass which is 400, so it's 0.25 moles. Next, number of moles of iodine is equals to 127, the mass, divided by the mR of iodine. So let's take a look. So iodine has a AR of 127, so I2 will have an AR of 127 times 2. So it's 0.5 moles of I2. So you notice that the mole ratio of the compound, the hydrocarbon compound, is to the number of moles of iodine is 0.25 over 0.5 or 1:2. In other words, 1 mole of the polyunsaturated compound reacts with 2 moles of iodine. So this means that it has 2 CC double bond inside it. Okay, so it will need, so we know that the answer is B. So if you have 2 CC double bond, then you'll need 2 moles of I2 because you need to put I here at this CC double bond here. And also you need to put another I2 here when you break this double bond here. Okay, so the answer for question 40 is B.